Okay, this is on 2.6 on special functions. There are three special functions we're going to go through. Piecewise defined functions, the step functions, and absolute value functions. And I'm thinking that you probably did not have any of them. Did you? Okay, so we're going to go through them and I know I have graph paper up here just to make it a little bit easier, but you can do it on your notebook paper, that's fine. Okay, so the first one is a piecewise defined function. And notice it is a function, so that means no 2 points should line up and down, and they will all pass the vertical line test if it's a function. And I'm going to do this just by example first. We'll go through a couple of examples. Okay, they will ask you to graph f of x, and remember that's the same thing as y, and they will usually use a little brace here, and they'll give you 2 or 3 things over here. So the first thing we're going to graph is y equals x minus 1 if x is less than or equal to 3. Then we're going to graph y equals negative 1 if x is greater than 3. Okay, so you do this one first, okay, and graph that. Okay, so, and have your erasers handy, because you're probably going to use your erasers, and I will probably mark on this and then erase it too. So this is saying it's like this: y equals x minus 1. If we just graph that line, it's in the form y equals mx plus b, and we always graph the b value first. So if you want to just watch up here, I might save you some erasing. Y equals x minus 1. So it's going to go through at negative 1. Slope is 1 over 1. So that's rise over 1. You'd go up 1 to the right 1. You'd go up 1 to the right 1. Up 1 to the right 1. So basically we have a line coming through like so. Okay? But it's only true for x less than or equal to 3. So I actually need to stop this at x equals 3. So it actually stops here and then goes down. Okay, so this little part I would erase. Okay? Okay, so I'm going to try to erase that. There. Okay? And it's equal to, so it's a solid point. Okay, then I need to graph this part right here. Okay, so I need to graph y equals negative 1 if x is greater than 3. What's y equal negative 1 going to graph? Y equals a number. Horizontal line. So at y equal negative 3, it's going to graph, or y equal negative 1, it's going to graph a horizontal line, but it's only true for x greater than 3. So we're looking at this line right here, and it'll continue, but it's not equal to because greater than or equal to. Okay, now, is that graph a function? Does it pass the vertical line test? Yes. Yes, because this one's an open circle, this one's a solid point. Yep. So if I did a vertical line test, it's only going to intersect one point all the way through. Okay? If I said on this, what's the domain of this graph? What x values am I using? If I continue this graph, what x values? All of them. So the domain of this graph would be, the domain would be all real numbers, right? Okay. For the range, if this would keep going down, right? So it goes, the range would go, where does it stop? It's actually negative infinity to, what's the y value? 2, right? So y is less than or equal to 2. Okay. So for that, the range is y is less than or equal to 2. Make sense? Okay, that's your first piecewise graph. Let's try another one. Okay, and I'm going to switch to a bigger pen here so you can see it better. Okay, so the next one is a three-part piecewise graph. Okay, so it's f of x equals, okay, and then you use a big brace. F of x, and that's the same thing as y equals -4 when x is less than or equal to -2. Y equals x minus 2 when x is greater than 2, -2, and less than 2. And then y equals -2x plus 4 when x is greater than or equal to 2. Okay, so first we're going to do the y equals -4. Y equals a number, horizontal line. So we're at -4, but it's only true when x is less than or equal to -2. So equal to -2, x equal to -2, and we need down to 4. And it's equal to, so that's a solid. This is controlling whether it's open or solid. Okay, so it should go this way. You agree with that? Okay, for the next part, we're going to do this. So you're graphing y equals x minus 2. And this, you may want to just watch for a minute, and then I'm going to have to erase. Okay, so y equals -x minus 2. So it's going to go through at a -2, and the slope is 1 over 1. So go to the right one, up 1, go to the right one, up 1. So I've got a line coming through here, but it's only true for x greater than -2. Well, there's already a point there. It would be like an open circle over a point. So isn't that solid? And it's x less than 2. Ooh, less than 2. I'm going to 4. X less than 2. So isn't this an open circle then? You agree with that? No, the x is 2. Yeah, you're thinking the same thing I was. The y, yeah, that's where the x. So this part of the graph is between -2 and 2. Okay? Make sense? Okay. Okay, now this next part we're going to do y equals this part. Y equals -2x plus 4. Okay, so that would go through slope at 4 and a -2 over 1. So rise over run. It goes down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. But it's only true for x greater than or equal to 2. So greater than or equal to 2 would be this x value, and greater than. So that's the only part I need. Okay? So that fills that hole in, and then, oh, sorry, that should be right there. Get the idea? This point is gone. This point's gone. So that whole thing is my graph. Okay? And it's solid points everywhere on that one. There, you have an open circle on one, but then you fill it in on the next one. Okay? Okay. Everybody done copying that? Getting that down? Okay, those are two examples of piecewise graphs. Okay? Okay, now we're going to go through the next special function, and it's called a step function. Did you do any step functions? A step function is actually one that almost all of us have to experience, because when you take something and mail it through UPS or something like that, or the U.S. mail system, you pay so much for the weight, and then when the weight goes up, you pay another value, and then the weight goes up, you pay another value. So it's called a step function, and the most famous one is what they call the greatest. There are several step functions, but this is the greatest integer function. There's the floor function, there's the ceiling function, which we get into in calc, but we won't in here. The greatest integer function. Okay, and it's a step function. Okay, the symbol that they use in the book is y equals, and if we're just graphing the greatest integer function, usually they use a symbol like this. Sometimes I just use the bracket, but in the book I noticed they use kind of a double bracket. So if you see that, that is not absolute value, that is the greatest integer function. Definition: it's the greatest integer less than or equal to x. It's the greatest integer less than or equal to x. Another way to say that is it's the integer to the left of x. Now, before we're gonna graph just that y equals the absolute or the greatest integer x. We're gonna graph that one. Before we do that, I want to look at a table of ordered pairs, and then our y is the greatest integer. And just use the bracket. So, if I look at my x value is -2. And if, in the book, they're just going to figure, they're going to write it like this. Okay, so they want to know what y value, what's the greatest integer less than or equal to -2. Think about just a number line, not a coordinate plane. If you were just on a number line, if I was just on a number line and I had all these integers, okay, all these integers out here are less than or -2, less than or equal to -2. What's the greatest one? -2. So that's our value, -2. If you did -1.8, what is the integer to the left of -1.8? No integer. What's the integer? -2. -1.6. What's the integer to the left of -1.6? -2. -1.4. -2. When you get to -1, what's the greatest integer? That's -1. What about -0.7? What's the integer to the left of -0.7? -1. Okay? And then it goes on. -0.5 would be -1. When you get to 0, it's 0. Okay, so when we start graphing that, okay, at -2, we'd go up to -2. Oh, sorry, down to -2. -2 would go down to -2. Okay, and then -1.8, we're at -2. -1.5, we're at -2. And then all of a sudden we get to -1. And -1 jumped up to -1. So this becomes an open circle here. I better not use that big point. Hang on. Okay. So it's going to go solid point and a solid line, and then an open circle, and an open circle, and then it jumps up, and then it's going to go an open circle, and it's going to jump up, solid line and an open circle, solid point, solid line, open circle. The idea? See why they call it a step function? What? I'm just graphing those ordered pairs. Okay, so like if I graph -1.8, -1.8 was -2, -1.6 was -2, -1.2 is -2. But as soon as you go to -1, it jumps up. Okay, so that's why you have to have an open circle. Okay, and then -1 is -1. Say that again? what is the value of -1? What's the y value? Yeah, so you go -1 down to -1. Okay, but as soon as you go -1.1, okay, then it's down to -2. Okay, so you got to, okay, so that is the step function. Okay, now let me give you an actual example. Okay, let's go through it, because some of you go through things where you have to pay. UPS would be one, FedEx would be another one. Sometimes when we pay our federal taxes, we pay, you know, if you make so much money, you pay this much and a percentage. Then when you go up to another category, if you make so much money, you pay so much and a percentage. So if you pay taxes at all, if you work a part-time job and you pay taxes, you're actually in a step function, whether you want to be or not. Okay, so here's an example. So one psychologist charges for counseling sessions. For counseling sessions. Spell that better. Or at the rate of, sorry, at the rate of $85 an hour. Okay, per hour for any fraction thereof. So, in other words, if they work 15 minutes working, they're going to charge you $85. Okay. Yep. They're going up. Yep. Okay. Draw a graph. To represent this. Okay. First, I would ask, if they don't work at all, what did they charge them? 0. As soon as they work a minute, what are they charging? $85. So, and I'm actually going to do this. I'm going to do this one without the graph. I think it will go better. Okay, so let's just do a sketch. So, if this is, let's go first hour, second hour, third hour, you'll get the pattern. Okay, at $85 an hour, okay, they're not going to make any money. Look where that open circle is. As soon as they work a minute, they are going to charge you $85. So this is solid, $85, no matter what fractional part of that hour. Then when they get to 1 hour, 1 hour's worth, $85 an hour. Okay. As soon as they go up and they work 1.1 hours, what's it go up to? 85 times 2? 170. So as soon as they go up, at 1 hour up here, it's an open circle, but as soon as they go over that, it's a solid $170. Okay? At 2 hours, you're paying $170. Okay? Then when you go up 2 hours up here, be 100, what is it, 255? Is that right? 255? That's an open circle, but as soon as you work a little bit more than that, you're making $255. So you get to 3 hours, that's a solid 200. See the step function? Yeah. Yes, for any, but think about, you know, I mean, this is just one example, but a lot of people work things on a step function. Say, I'm going to charge you, I don't know about plumbers, you know, and a lot of you are in some kind of a step function, I would think, on your cell phones. I don't know. You might be on a step function so much, no matter what. I don't know. Okay. So, yeah, that's a possibility. I'd have to look at them. Okay, so we've done piecewise graphs, we've done 2 examples of step functions. Let me show you how to do it on the calculator. Yes. Okay. Okay. I want to do this step function on the calculator, one of them. Okay. I'm going to go all the way back to this one. The y equals, we're going to do this one on the calculator. Real quick. You know it's a step function, and it's a function because no 2 points line up and down. You notice some of them are open circles, some are solid points. Okay, go to the y equals. Get your cursor on the y equals. Math key right below the green alpha key. Go to the math key. Math key.
Oh, the one that's math.
Oh, yeah, it actually says math. Yeah.
Okay, right over to number.
Math.
Number 5, int for integer. Okay, number 5. Integer x. That is the greatest integer function. Now, I will tell you that you have to be in the right window, the right mode for that to show up. You have to know that it should look like a step function. Okay, so do zoom for me. Do zoom and zoom 4. Mine is connected. Okay, so on mine I have to go to the mode key, and on mine I probably have to go to dot mode. And why did we do that a minute ago? What was the correction? Turn your stat plot off.
Oh.
Second function y equals. We turned it off a minute ago. Okay. Okay. So you may have to go to dot mode. You may have to go to either zoom integer or zoom decimal. But you should know what it should look like. Okay? So we did, to get this to work, we got the cursor at y equals. Okay, then we did, go back to that. And then we did the math key. Make enough notes so you know what to do. So we did the math key, and then we did a right arrow over to number, and we did number 5, which was int. So on the calculator, it looks like y equals int parentheses x. Then you have to check the window. I did zoom decimal on some of these. I did zoom decimal, or I might do zoom. Let me see if zoom 8 works. No, my zoom 8 did not work. Okay, so you have to go to dot mode, okay, and go to zoom decimal. See if that works. Okay, so how do you tell if there's an open circle there or not? Okay, so you go second function, calculate right above the trace key, and let's check the value at x equals 0. Do value at x equals 0. Second function, calculate right above the trace key. Okay, now, if there's something there for the y, if x equals 0 and y equals 0, that means there's a solid point there. Okay, now do second function, calculate value at x equals 1. Okay, notice, now you can't see it on here, but there is you can put the trace key on, and there is a line going through from 0 to 1 at y equals 0. So that means that this ends the open circle. This is the solid point. This would be an open circle, and it'll jump up to a solid point. Okay? So you can do some of these graphs, but you have to play with the window and make sure you get a step function. You know you should be getting a step function. Okay, last one, the absolute value. This is another special function. It is the absolute value. The absolute value function. Okay, and they will ask you to graph y equals the absolute value of x. Okay. Now again, a lot of these, and even my piecewise, I will tell you the piecewise graphs on all these, I would try graphing them by hand first before I'd ever go to the calculator. You can't, my calc kids always remind them, you cannot totally trust these calculators. You have to know what you're doing. Okay? Okay, we will start there tomorrow. Okay, so we're going to make a table of ordered pairs on this one too. You can always do these by hand. So if x equals 0, y equals 0. If x equals -1, y equals the absolute value, that's 1. If x equals 1, y is 1. If x equals 1.5, y is 1.5. X equals -1.5, y equals 1.5. X equals 2, y equals 2. X equals -2, y equals 2. And then graph that. So we should have a point at 0, 0, -1, 1, 1, 1, -1.5, and we'd be about 1.5. -1.5 would be up to 1.5. 2, 2, -2, 2, and you end up with a graph that looks kind of like a V. Okay, and that's the graph for y equals the absolute value of x. If you go onto your calculator and do y equals, and then do the math key, then write it over to number, and then you'll see ABS for absolute value, so you can do y equals the absolute value of x, and graph that. And I would do zoom, zoom 6 for zoom standard, and then I would switch over to zoom square, zoom, I think it's zoom 5 for zoom square, and that makes it look more like the absolute value graph. The domain of this, the domain, the x values, we're not leaving out any x values, so the domain's all real numbers. And the range, the first y value is 0, so, and greater than that, so y is greater than or equal to 0 for the range. Okay? And then you probably need graph paper on the assignment, so do these by hand first before you just go to the calculator.